simplifying radicals. We'll start with a square root, and we'll build on the same concept with a two other cube root question. A square root, a lot of times this would just be written like this, and it's assumed that the number 2 is here. Okay, so just keep that in mind. I drew it in so that we could see the relationship between it. And we have to find the square root of 27. And when we're simplifying, let's just assume we don't have a calculator with us, or we want to have an exact answer. And that's usually the reason. You want something that's exact, because we would get probably a repeating decimal, and we'd end up rounding, which is an exact answer. So that's usually a reason to simplify a radical. So the square root of 27, well, I can quickly think about this. What numbers fall around that? We know the square root of 5, or 5 squared is 25. And then 6 squared is 36. So it's a number in between there that's going to be some decimal. So it's not a whole number. So what we can do is we're going to look for numbers that actually multiply, so factors of 27, that are perfect squares. Okay? In other words, you can square root them and get whole numbers. So if you need to, you can always kind of write out factors to help you with this. You have 1 and 27, and neither of those work. And then we have 3 and 9, I think, are the only other ones. And 3 times 9, 9 is something that we can square root. So what we're going to do, and maybe I should move this to the side here, move it down a bit, we're going to split this. Okay. Essentially what we're going to split it into is the square root of 9 times the square root of 3. And these two values multiply to our 27, so this is kind of like splitting the equation. Okay. It's still the exact same thing. I didn't write the 2's in because, again, the square root just means squared. And we can find the square root of 9. Do we know what the square root of 9 is?
3.
It's just 3. So now we have what you can consider like a coefficient in front of our root 3. And this is really as simple as we can get, because this here is a prime number. Right? 3 is a prime number. It would only split into 1 and 3, and neither of those, well, we can square root 1, but that's not going to help. We're still going to have the square root of 3 here. So that's how we know we're at our simplest form, that we can't really split this any more times. Okay? Does that idea make sense? Okay, so let's go to try to apply this to a cube root of a number. Same idea. We need numbers that multiply by themselves 3 times to get 54. So off the top of my head, I know the cube root of 3 is 27. Cube root of 4 would be 16 by 4. I don't know it off the top of my head. So it's going to be 40, 50, 64, I think. So it's going to fall between 3 and 4. So it's not a whole number. So let's do the exact same thing. Let's find some factors. Maybe we'll do this one in red. We'll find some factors of 54. And we have to think of numbers that can be cubed. Well, obviously there's 1 in 54, and these two don't work. Okay. We have 2, and how many times? 2, 7, 27. Cube root of 2, there is no number times itself 3 times. Cube root of 27, I think I mentioned it before, but we can find the cube root of 27. Do you know what it is? And if we're unsure, what we can do is, again, let's assume we don't have a calculator for this question. We can just test numbers, right? If I go 2 cubed, that's 2 times 2, which is 4, times 2 again is 8. Okay, that's not quite what we need. And you can always make a list on your side if you're working with cube roots. 3 cubed, 3 times 3 is 9, and then 3 times 9 is 27. That's a value that we can find the cubed root of. So let's go into splitting this, what we have above, into the cubed root of 2 and the cubed root of 27. Okay, cubed root of 2, well, obviously, and again, if you're unsure about it, just go 1 cubed. Well, that's 1, right? If we're working with just our natural numbers, whole numbers here, you can make a list of values that work out to be cubed. So we know 1 is 1, 2 to the power of 3 is 8, 3 to the power of 3 is 27. So already, it's a really quick jump. Anything in between there is not going to give us whole numbers. So we know that this doesn't simplify. But we did figure out that 27, the cubed root of 27 is the value of 3. So though I've written it to the right, and I'll solve it to the right. I can move this down so we have a little room. There we go. This ends up being cube 2 times the value of 3. And what you do with that 3 is just kind of move it to the front like a coefficient that we had over here. So we have 3 times the cubed root of 2. And we know we can't go any farther with 2. We're looking at our list of cube roots, and that's all we get for that one there. Okay, so that's simplified as far as it can go. And we have Pretty big number here. Our strategy is just going to work with small factors and constantly breaking down small factors, okay? So the very first set of factors, we know that 2 will go into this, okay? So 2 will go in, and I'm, again, trying to do it without calculator. Or maybe, you know what, we can do it with calculators. Let's do it. How many times does 2 go into that?
50,625.
Okay, 625. So these are our 2 factors. So this breaks down into the 4th root of 2 and the 4th root of, let's make sure I write it down right, 5625. Okay. Well, this is something, our 4th root of 2, it won't break any lower, so we know that's something we've got to work with. 5625. We have a 5 at the end. So what do we know will go into that? 5. So let's break that. It's going to be a factor of 5, and something will be a factor of that. So we have 4th root of 2.
It would be 10,125.
Hey, all right. This is going to be important to us. This breaks into 4th root of 5 and the 4th root of 10,125. Okay. What goes into 10,125?
25.
Oh, does 25 go into it?
Yeah.
How many times?
405.
Oh, that's good that you noticed that. So let's write this down. We have 4th root of 2. I was going to split it into another 5. But if you can see that, that's a good one to test. 4th root of 25. 4th root of, and what does the other number become?
405.
405. Okay. Now, we know 25 can be split into the what? Question. Breaking it down. We can break 405 into what?
Into 5.
What did you say were the numbers?
5.
5 goes in, yeah. 4th root of 5. And how many times does that go?
4th root of 81.
Okay, so we got some pretty good values here. This doesn't break down, but it does break down into another set of numbers, okay? And I want to break 25 up. How can we break 25? What times what equals 25?
5 and 5.
Yeah, so let's just break that into another set of, and again, we've been breaking these on the side, so I should be putting our little arrows here. Okay, 4th root 5, 4th root 5, 4th root 5, 4th root of 81. Now that's something we recognize. 4th root of 81 is what value?
3.
Okay, so times 3 at the end. This is great. So we have a coefficient of 3, and then I got a whole bunch of 4th roots to the 5. Let's just think about the pairing. I'm going to show that quick idea again. Remember, if we have the square root of 9 times the square root of 9, what are the square roots of 9? They're
3
and 3, which equals the value of
9.
Yeah, so what it's saying is you can multiply our values like this. Now, what I want to show you, if that works with square roots, and I'm going to show you why that works with square roots and how it's going to be a little different for this one here, okay? In our square roots, do you know how to write a root as a fraction? Or sorry, as an exponent. I apologize. I gave it away. The answer.
Oh, it's 1 over 4.
Yeah, so in this case, 1 over 4. If it was a square root, 1 over
2.
2. So the reason that works for square root is you have 9 to the power of a half and 9 to the power of half. Well, to simplify exponents, you add the halves together, and what do you get? 9 to the power of 1. Here, let's simplify all those bases. I'm going to keep this 2 the same. 4th root of 2. This becomes 5 to the 4th times 5 to the 4th times 5 to the 4th times 5 to the 4th. And when we add up all of those quarters and still times 3, quarter and a quarter and a quarter and a quarter, do you know what that equals?
1 over 256.
You're multiplying. Remember when you're adding exponents, you just add the fractions. So that'll actually be 4 over 4, which is the value of 1. So we have 4th root of 2 times 5 to the power of 1. What is 5 to the power of 1? Just 5. So times 5 times 3. Okay, and these are our coefficients. We'll move them to the front. 5 times 3 is 15 times the 4th root of 2. And there you go. You've now broken it into what looks like a much more simplified version of what we had. What did I have down here? Oh, a bunch of factors we were working with before. Okay, so a difficult question, many, many steps, but it can still be simplified using, simple division in numbers that we are able to kind of fathom.